record to the cloud. Right, well, welcome everyone to a rainy and welcome rain Vancouver. I will open on behalf of Andrei Kaminsky, who is dealing with an emergency and will hopefully join us as soon as possible. So tonight we will open with Owen Rogers, who will share 6 tools that you can apply right now to start reducing the carbon impact of our IT services. And thereafter we'll switch to Ephemeral Environments with Roost by Rishi and Sudhir. So this session is being recorded and will be shared on our Meetup YouTube channel in about a month's time. Please mute your microphones during the presentation and obviously remember to unmute for Q&A. We need your feedback as always to improve the Meetup and your ideas for future sessions. And it now gives me great pleasure to introduce Owen Rogers, who as a technologist, coach, product manager, and leader helps organizations bridge gaps and break down silos through the application of agile principles and practices. He is passionate about leveraging technology to make the world a better place and to tackle the climate crisis. So Owen, welcome, and the virtual planet is all yours.
All right, thanks, Willie. Let's get going. All right, so I assume everybody can see my screen at this point in time. First off, welcome. Thank you very much for joining for what I hope is a useful talk and an important topic. I hope that you come away from this with some new ideas and things to try within your own place of work. So there's going to be lots of resources that I mentioned in the deck. So somebody from DevOps Vancouver is going to be kindly helping out and posting some of the links of some of the things that I'm referring to as we go through this. And then I'll share the link to the deck after the talk. So, you know, if there's things that you miss, don't worry, you'll be able to get access to it. All right, so I imagine it comes as no surprise to anyone here attending this talk that anthropogenic climate change is happening. Its effects are getting more severe. The last 5 years have been some of the hottest on record, with massive heat waves, storms, floods, and other disasters around the world. Just if we think about this past summer in Europe, we saw temperatures break 40 degrees Celsius in areas that had not seen those kinds of temperatures before. From an IT perspective, it led to rolling blackouts, including some data centers that temporarily had to suspend operation. And of course, heat-related deaths just due to the extreme heat. Or if we think about the floods that have just been afflicting Pakistan, almost a third of the country has been underwater. The waters have subsided somewhat, but the country is now facing an epidemic of cholera and other waterborne diseases, not to mention the starvation from ruined crops. And closer to home in BC, I think we all pretty keenly remember the heat dome from last summer. It caused over 600 heat-related deaths across the province, and it sparked a fire that burned the town of Lytton to the ground. And then that was followed by heavy rains last November, causing the Sumas Prairie to flood, putting the Trans-Canada Highway underwater. So it's really a reminder that the West Coast, the West Coast was basically cut off from the rest of Canada, and it was a reminder of how vulnerable our supply chains are. So for all of us, I think at this point in time, climate change is a lived reality. It's not just something that is happening in some distant hypothesized future. It's here, it's affecting us right now. And I mean, it may be hard to appreciate given the rain that we're having right now, but we have been in drought conditions across the province, with many areas facing water restrictions and very low reservoir levels. This photo here is from Alouette Lake out in Golden Ears. So just seeing unprecedented low levels of water in that area. In fact, up until this past week, BC has had less precipitation than the Mojave Desert since July. So that's, to me, is just crazy. And we live in a temperate rainforest. So in the face of all of these impacts, it's easy to feel helpless and powerless. Something we can't do anything to stop climate change. It's not like most of us are working on the next generation of solar panels or other fuel cell technology. Most of us, I would imagine, are working on a web service or a website. And it feels a long way from anything that is directly polluting or harming the planet. So it's hard to feel like we can have an effect directly. But that's not entirely the case. So given that we work on internet-related applications, the internet itself accounts for approximately 3.7% of global emissions. That's about equivalent to the airline industry. So I think it gives you a sense of how big the impact is. If the internet was a country, its emissions would be equivalent to the world's 7th largest emitter. So basically right behind Japan. So it's not like what we are doing has no impact. So effectively, we are part of the problem. But the upside of that is we can also be part of the solution. So those websites, web applications that we're managing, they run in a data center somewhere. Those data centers are huge consumers of electricity. In fact, in the US, data centers are responsible for about 2% of American electricity use. And while some data centers have on-site renewables like wind or solar, most are just drawing electricity directly from the local grid. And for much of the world, including in many regions in Canada, certainly many regions in North America, that electricity is generated by fossil fuels, specifically coal, oil, or natural gas. So the first thing of the 6 ways that DevOps can help tackle climate change is to use eco-friendly hosting. So think about where your applications, your services are hosted, and what the climate impact is of those data centers. So here's one thing that you can try. I encourage all of you to do this right now if you haven't done this before. The Green Web Foundation is a European-based nonprofit. They operate this service called Green Web Check that has the largest database on the internet of data centers that are powered using renewable energy, or where the data center provider has paid to offset the carbon emitted from the electricity that they're using. So you can enter in your the URL for your website, and what the service will do is it will look up the IP address associated with your site, and it will compare that against what they have in their database, and it will give you something that looks like this. So I know that there's folks on the call from WorkSafe BC, so I looked up WorkSafe BC, and in virtue of being hosted in Azure, you're already using a green data center, and we'll talk a little bit more about Azure in a sec. If your site is not listed in the database, you'll see something that looks a bit like this. I mean, that could mean either that the data center that you're running in is not green, in which case you might want to consider moving to an alternate data center if that is something that is feasible. Or it's also possible that your data center may in fact be green, but it's just that the providers haven't registered themselves with the Green Web Foundation. If you have sway, then perhaps you can try and influence them to go and register. But this is a useful tool, and this tool forms the foundation of a number of other services that I'll be talking about later. Other factors to consider are things like how effectively the data center uses the electricity that it consumes. So within the industry, there's something known as power usage effectiveness, which is basically the ratio between the electricity consumed by equipment that is like computing equipment, so directly used to perform computational loads, versus equipment that is used in support of that. So, or just in the general operation and maintenance of the data center. So that might be cooling or air conditioning systems. It might be lights, etc. And so a number of data centers will publish their PUE, and in general, the lower the better. So that's something to, if you are evaluating a data center, something to consider. Even for green data centers, it just because of the fact that they may be receiving electricity from a renewable source, there's generally still some emissions associated with it. Or for, let's say, Azure, it doesn't mean that all of their data centers are powered by renewable energy. It may just mean that Microsoft has purchased carbon offsets. And carbon offsets are certainly not as good in terms of mitigating the effect of climate change, certainly not as immediate as preventing those emissions from being released in the first place. Another thing to consider is also the huge amount of e-waste that is produced to support data centers. So how data centers handle that e-waste can be a contributor to climate change and cause additional emissions. So really what we're looking for is data centers that are best in class in terms of their energy efficiency, how they manage their supply chain, and how they deal with waste. And really, for better, for worse, if you're looking for best in class, it generally means considering the top 3 cloud providers, Amazon, Google, and Microsoft. They just have the scale of operation that exceeds so many other data centers out there. There are some great smaller data centers, especially some of the ones based in Europe and Switzerland, have some very clean data centers running on renewable energy. But for the most part, the large cloud providers are good places to start. So we'll look at each of these in turn. So I'm going to start with Amazon, in part because it's what I'm most familiar with, and it's also the largest. So if you're running within Amazon, Amazon has 5 regions that would be considered to have low carbon emissions. So here within Canada, there's CA Central 1 that's in Montreal. Now, the reason that it's considered to be low carbon is that it is just using electricity directly from the grid. And in Quebec, the majority of electricity is produced via hydro. So that is considered to be clean. The default AWS regions that people typically run in to get started, like US East 1, based in Virginia. Virginia largely gets electricity from burning coal. Part of the reason that there are a lot of data centers in Virginia is because of the fact that electricity is inexpensive due to the embedded coal industry. So if you are running within AWS, I highly encourage you to, and you care about the climate impact of the services that you operate, I highly recommend considering moving or running out of regions that are that have these green leafs associated with them. So moving on, looking at Azure. So Microsoft has made a pretty strong commitment to being climate friendly. They have been carbon neutral since 2012. And they have a goal of 100% of the electricity in their data centers coming from renewables by 2025. Now, something like that is quite challenging to do given the global scope of a number of these cloud providers. I think that's part of the reason that Amazon's not there yet. I mean, if you're running a data center in Australia or in South Africa or in parts of Asia, it's really hard to procure electricity generated from renewable sources. So that's what Microsoft is working towards, and it doesn't mean though that the electricity that's used in that data center in Asia is necessarily renewable. It's just that they have purchased enough electricity in other locations in order to to account for it. If you're really concerned about sustainability, Google is by far and away the best. They operate 10 low carbon data centers. They've been carbon neutral the longest. They already procure 100% of their electricity from renewables. And their goal by 2030 is to use carbon-free energy everywhere at all times. So the all times part becomes quite challenging. Like even here in BC, where most of our electricity is generated using hydro, we still will trade electricity with other regions. So for example, in BC, we might purchase electricity from Alberta, which might be generated from other sources at certain times of day in order to hold off from releasing water from behind the dam, and then sell that electricity back to Alberta at other points during spikes. So even though most of our electricity comes from renewables in BC, we can't say that there's no emissions because of that kind of emission trading that occurs. Anyway, so Google is great. Azure is great. Amazon has got some work to do. They have made some commitments, but they still have a fair bit of work to do. All right. So the second way that you as a DevOps engineer, a software developer, a technologist can help reduce the carbon footprint of the services that you're operating is to apply a growing list of what are considered green architectural principles. So there's a few resources that you can check out that have information on this. So one of the first is principles.green. It's a website that's set up by the technical sustainability lead for Microsoft. The essence of it is really just focusing on the carbon impact of the services that you build, ensure that what you're building is energy and hence carbon efficient, makes efficient use of hardware. You're trying to use hardware that has low energy use. Another consideration, which is we'll talk a bit more about later, is really focusing on minimizing the amount of data that is transferred out from your service, must travel across the network. And then the key thing, which we'll also go into in more detail later, is start to measure your carbon footprint, understand what your carbon efficiency is, and then take steps to optimize it. So another approach that I want to mention, which is a bit more prescriptive than the Green Principles one, is a new initiative called Roll the Cloud, which is focused on basically trying to eliminate servers. I mean, not really servers, but at least dedicated servers for running your infrastructure. So you can imagine this is basically manifest as relying on static site generation and then leveraging lambdas or cloud functions in order to power everything that you need, and then move to data stores that are effectively either powered on demand. So something like within AWS, there are like Lambda RDS, which basically means you don't have a standing database instance. Queries will be handled on demand. So technology like that. Anyway, I think what they're proposing is pretty interesting. So if you're looking for something a little bit more prescriptive, you can check them out as well. And then within the cloud platforms themselves, both AWS and Azure have published their well-architected frameworks and have added a sustainability component to it. So for those who are familiar with the well-architected framework, it's a set of best practices provided by the cloud operator, explaining what the recommended approach is for building an application on that cloud platform. So they provided additional advice about sustainability. So you can check those out as well. I've included links to that in the session notes. And so a lot of this lines up with recent trends within, certainly within web technology, whether you're considering something like Jamstack, moving towards more static server-side rendering. Capri and Astro are newish frameworks for doing something like that. 11T is a more I would say, considered a more venerable framework for doing static site generation, but it's very much I think the way that a lot of sites are moving, and there are cloud benefits associated with doing that. This last icon that's presented over here, this is Druid CMS, something that was built by the Roll the Cloud folks, with the goal of having a CMS that meets the objectives of that Roll the Cloud approach. So no databases, no servers, focus on static site generation, etc. All right, so that's just a high-level overview of some of the green architectural principles. There's a bunch of benefits, ancillary benefits associated with taking this type of an approach. I mean, it's aligned with what would be considered to be other architectural best practices. Generally, it will help you produce a lower cost solution. So if you consider you're going for static site generation and leveraging cloud functions, it's going to be generally a lower cost solution than persistent instances and dedicated database servers. It can lead to better performance, certainly better scalability. Static sites are generally going to be a lot more performant than any site that requires server-side rendering from a database. And a lot of this is supported by infrastructure automation. Infrastructure automation gives you that flexibility to be able to move to a different region within your cloud provider, or to a different cloud provider, depending on the sustainability characteristics of that provider. I think these are also great problems for developers to work on. I mean, we all like working on optimization problems and trying to optimize and minimize the carbon footprint of the site that you're working on. Is quite a rewarding activity. And so I'm giving these as examples of ways in which you can justify doing this type of work. But I mean, really, sustainability shouldn't need additional justification, especially given the crisis that's in front of us. All right, so the next way is to measure your carbon footprint. So I'm going to give you some advice in terms of how to do that. On the surface of it, it's when at least when I heard about measuring carbon footprint, I thought, well, okay, this is something that we need to bring in a qualified third party to help us out with and to analyze our use and provide recommendations. But the more that I dug into it, number one, it's hardly rocket science, and two, for the most part, any auditor that you bring in is going to, in all likelihood, require your services in order to provide them with the data that they need in order to be able to calculate your footprint. So I'm going to give you a very quick overview of an approach in terms of how you can calculate the carbon footprint of the website or service that you operate. So first, a little background, just help you understand what the language is. So if you're looking at any sort of carbon reporting, there's what's referred to as Scope 1, Scope 2, and Scope 3 emissions. So the easiest way to think about Scope 1 is any emissions that your organization produces directly. So for example, if you work in an office building and that office building is heated using natural gas, then the carbon emissions from that natural gas would fall within your Scope 1 emissions. Scope 2 emissions is basically associated with emissions that derive from the electricity that you consume. And then Scope 3 emissions represent effectively everything else. So these are what would be considered indirect emissions. So normally these are emissions that are Release is a product of delivering your service, and that might be through your supply chain, etc. So if you don't operate, so if we think about a web application, if you don't operate a data center that your application is running in, you're probably focused on calculating and minimizing your scope 3 emissions. That's where your digital services will fall. If you actually run a data center, then you would be directly accountable for measuring your scope 1 and scope 2 emissions. But anyway, that's a little bit of theory to get you started. So far we've been talking about, thinking about the emissions associated with the data center. So we can see that the electricity or fossil fuels that are consumed within the data center would contribute to greenhouse gas emissions. But if we widen our scope a little bit, your service is not being provided in isolation. It doesn't exist solely within the data center. Really, you are you're providing data to some third party, your end user, your customers, and that data needs to transit a network, the internet. And that network, there is going to be electricity consumed powering the devices within that network, and that electricity is going to produce emissions. So what I recommend and what is considered to be best practice is to start to incorporate the emissions associated with the transmission of data across the internet as part of your carbon footprint. So extending that out even further, then we get into, that the data from your website is ultimately flowing to a user on their device. So and that for the device to render your website or service, to do any sort of data processing, that is going to consume power on that device. That device is going to be charged or powered based on the grid wherever your user happens to be located. So that, again, emits carbon dioxide and other greenhouse gases. And then the fourth thing to consider is that inherent in all three of these things, the data center, all that networking equipment, and the devices, is what's called embodied carbon, which is the carbon dioxide that would be emitted to manufacture those devices. So if we want to think holistically in terms of our footprint, we want to take some accountability for our share of the emissions associated with all four of these things. And that can seem a little bit overwhelming, but I'm going to introduce you to an approach that provides a very simple way to account for all of this. So the approach that we're going to talk about today is called the sustainable web design methodology. It's used by some of the, and it was developed by some of the services that I'm going to talk about a little bit later. But it's worth having just a kind of quick overview in terms of how it works, so that you can do these calculations yourself, because it's not complicated to do. So the key thing about this approach, which simplifies it, makes it very easy to work with, is that it's all focused on the amount of data that is transmitted from your website or service across the internet. And so that's nice because of the fact, excuse me, that's something not only are we able to measure, but we also have some ability to control. So how is this manifest in our carbon calculation? Well, what the authors of the standard did was that they calculated that on average, it takes approximately 0.81 kilowatt hours to transfer 1 gigabyte of data across the internet. And so that was calculated basically looking at the entire, an estimate of the entire electricity use of that's used to power the internet, divided by the total amount of data transmitted over the internet. And so that's where the 0.81 kilowatt hour number comes from. There's lots of citations in the in the methodology, so you can look into that if you need to. But you know, it's obviously anything that we're doing here is going to be an estimation, but for the most part, that's fine. It's going to give us at least an approximate sense of what our carbon footprint is. So how do we use this data? Well, what we're saying is that, okay, if it takes, if transmitting our data for our website or service across the internet to our users consumes 0.81 kilowatt hours per gigabyte, and we know how many gigabytes of data within a given period, per day, per month, per year, our service consumes, then we can start to calculate what the total energy use is associated with our website or service. So what the methodology does is it proposes apportioning a percentage of that electricity use to the data center. So 15% goes to the data center, 14% goes to the network, 52% is what's used to power the device, and then 19% goes to the manufacturing of the hardware that's used in these three prior components. So okay, if you so how do you figure out what your annual bandwidth is? So just some recommendations here. I think the easiest thing to do is if you're using a CDN, so content delivery network, most of them will include some sort of reporting that will enable you to pull out this type of metric. Or if you aren't using a CDN, but your application is fronted by a load balancer, generally load balancers will enable you to get this kind of data. In a pinch, if you're using an analytics solution like Google Analytics or something similar, you can also pull that data or calculate that data from there. But it's pretty lossy because of the fact that there are lots of there's lots of requests to your website that may not render JavaScript, may not get processed through Google Analytics. Anyway, my recommendation is check your CDN or check your load balancer, and you should be able to calculate this. So with this number, we can then start to apply some emissions factors. So if you know where your data center operates and you know what the carbon emissions are associated with electricity use in that area, then you can calculate the greenhouse gas emissions associated with the energy use for transmitting the data required by your application across the internet. For things like the network and the device, if all of your users are within a specific region, so let's say, for example, you service only Canadian customers or only customers within British Columbia, then you may want to use a more region-specific emissions factor. For the rest of us, if you're working on something that serves a global audience, global customer base, you can use this 442 grams of carbon dioxide equivalent per kilowatt hour factor. That's what's recommended by the protocol, by the specification. Just summing up these components will give you an estimate of your carbon footprint. So it's pretty easy to do, some simple spreadsheets, and maybe a day's worth of work. It will give you a pretty good sense of what your the carbon footprint is of your service. And then once you have that in hand, you can start to think about how can you optimize it? What can you do to drive down the amount of data that's being transmitted from your application? Because at the end of the day, that is the key driver in terms of this emissions calculation. If you're looking for emissions factors, I found this site to be pretty useful. It's got real-time electricity use and emissions factor calculations for quite a large number of regions around the world. So if you do operate out of data centers in quite a few areas, then having this resource can be quite helpful. All right, so just to kind of summarize, there's with this approach, the sustainable web design methodology that I've just gone through, there's a bunch of advantages. So number one, it's pretty simple. I've been able to hopefully explain it understandably within a fairly short period of time. and hopefully giving you enough information that you can go and calculate it on your own. Number two, it's pretty comprehensive. So you can see this is not just the emissions associated with the data center. This is trying to factor in the entire scope of the operation of your application. So thinking about your users, and because your application is not just running in isolation. Number three is it's adaptable. So you can, if you have better information about electricity use or emissions factors in your area, you can adjust it to be more accurate. Four, it's a published standard. And five, this focus on gigabytes of data transferred is something that we can optimize. We can use as the starting point for looking at our website and thinking about what we can do next, which comes to the next key way that DevOps can make a difference, which is to put your website on a low carbon diet. So what do I mean by that? I mean, that means going through looking at what are the resources that are served up from your site, determine, are we using image compression? Are we using far future expire headers? Are we just using standard HTTP compression? Are we using a CDN? Are there resources that don't need to be transferred? Can we use more modern image formats that will provide for better image compression? Are we stripping out unneeded JavaScript? Are we doing tree shaking for our script, or CSS includes? So that there's it provides the basis for a lot of work that developers can do in order to start to reduce that footprint. So this is a screenshot from DevTools. That's kind of what I've been using as the basis for this, because it does provide granular data. But there are some tools that you can try out yourself. So one, and I'll just go through these quickly. You can try out ecograder.com. So punch your website into the search bar, and you can check out what the results are. I quite like EcoGrader. EcoGrader is also using the sustainable web design method for doing their carbon calculations. Same for website Carbon. That's another similar one. I'm less of a fan of this one. I find that their recommendations are less actionable. Caster.green is another service that I actually like the most, because of the fact that it provides very granular and specific recommendations. Other services that you can check out. So so you might want to consider not just the resources that I'm responsible for, but what about the third-party services that I'm connecting to, third-party resources I'm loading on my app, whether that be analytics script includes, or ad beacons, or whatever else is going on to my website. I want to know whether or not they are also hosted in an eco-friendly data center. So this is a tool that can answer that question. So any of the prior tools, they're all giving you point-in-time snapshots of the data. ecoping.earth is a service that you can use that will on a daily basis go and assess the environmental footprint of your website. So you can track and see how you're trending over time. So that's quite nice. So they've got a free offering, and then a paid service that has got more associated with it. All right, so the cloud providers themselves also offer some emission calculation services. Now, generally, they're constrained to just what they're able to calculate for your account, cloud account. But I'm just going to quickly touch on them just to make sure that maybe you've heard of them, maybe you've tried them out. We can talk a little bit about what you think of them later. I'll give this one I've tried out. This is the Amazon Carbon Footprint tool. It is basically Amazon checking a box. It's really just window dressing. There's very little in the way of useful insight in this tool. Don't bother looking at it. Maybe given Amazon, it'll probably be significantly better by November or in another few months, but currently it's just not worth paying attention to. I haven't tried the one from Google. Sorry, it's a crappy screenshot. That's about all I could find. But I've heard it's decent. And then Azure also has an emissions dashboard that plugs into Power BI that you can check out as well. If you are operating in a multi-cloud environment, you may want to check out the cloud carbon footprint. I did play around a little bit with this one. It's fairly heavyweight. It does deploy to AWS. But if you're looking to try and collate data from, let's say, an in-house data center and a cloud environment, then it's a pretty powerful tool there. Okay, so a few more things before we wrap up. So the fifth thing, that's what I've talked about so far. Those are more the technical solutions. I'm gonna touch on more of the social side of things. So if you have sway within your organization, you can try and convince them to commit to going to net zero. So net zero is basically where your organization agrees to either both reduce and offset any residual emissions that are associated with your business operations. In a number of regions, this is being legislated. I mean, the legislation of this is going to be necessary in order for us to hit our targets, and if we have any hope of keeping the planet from warming by more than 1.5 degrees, we're really going to need to legislate this. But in the interim, that's the stick, obviously. But in the interim, any organization can get ahead of this by making this commitment proactively and starting to take the steps necessary to figure out what is necessary to get to net zero. If you are interested in becoming net zero and you want to be able to join a global movement of other organizations that are also getting to net zero, the United Nations Climate Secretariat is running a campaign called the Race to Zero, which is organizations that have pledged to get to net zero by 2050 at the latest, with a more significant emissions reduction target by 2030. I mean, obviously, we want to be able to reduce emissions as quickly and as early as possible. Now, for Race to Zero, you don't sign up directly. You need to go through third-party partners. So these are some of the ones that you would consider depending on the size of your organization. So if you're an SME, like where I work, check out the SME Climate Hub, super easy to sign up. You basically, and part of joining, you take a pledge on behalf of your organization committing to net zero and carbon neutrality. Business Declare is another one. They're based in the UK. But they're maybe a little bit more stringent than Climate Hub. If you're a larger enterprise, this is actually, I believe Amazon's pushed the Climate Pledge more for trying to line up enterprises that are making climate commitments. And if you're just an individual that are looking to sign up and commit yourself to sustainable goals, check out the Sustainable Web Manifesto. You can become a signatory there. Another thing, again, if you've got sway within your organization, try and convince them to declare a climate emergency. If you live in the city of Vancouver, like I do, Vancouver has declared a climate emergency. A number of other municipalities have done so, and organizations do so as well. So it's basically what it amounts to is a public statement committing the organization to climate action. And again, reinforcing your net zero commitments. So something good to push for. Now, you don't have to do all this on your own. Look for allies within the organization that can help you out, that you can back you up, that you can bounce ideas around with. So look to form a green team if you don't already have one within your organization, and you can discuss what actions you can take collectively in order to help your organization reduce emissions and make a climate commitment. All right, so the sixth and final way that you can help address the climate crisis is to join there's a broader community of technologists that are working on these problems, that are discussing these problems, and that are open for members. So some of the ones that I'm a part of that I recommend checking out. So climateaction.tech is they've got an open Slack group. It's mainly in Europe, but there's a growing contingent in North America. Lots of good green tech related discussion that goes on there. So if you use Slack already, it's an easy place to join. Similarly, work on climate, more North American focused, also a public Slack community that you can join. There's work that's going within the W3C consortium around sustainability and web technology. So you can check that out. You can join, you can participate in some of the committees. In fact, a couple of months back, there was a meeting here in Vancouver on that committee. If you're part of a larger organization, the Green Software Foundation has got a number of, they're funding a number of technology open source projects and initiatives that are working in the sustainability space. So that's something you can check out as well. And then if you want to more actively apply yourself in this space, you can consider some sites and career and job sites that are dedicated to helping individuals who want to have a climate impact. So these are a few you can check out. All right, so just in summary, 6 ways that DevOps can tackle climate change. So we talked about the impact of the data center that you're running your application in, and trying to find an eco-friendly alternative if you're not already running in one. Green architectural principles that you can apply to building or designing, either retrofitting your existing application or building new ones. I give you a quick tutorial in terms of how to measure your carbon footprint and where you can start to reduce the carbon emissions associated with your site or service. And then some things you can do within your organization more broadly, organizing to get to net zero, and then join the broader climate community. So before I wrap up, a lot of what I've talked about here in this talk is based on work that I've been doing over the course of the last 6 months with .eco. So I help operate the .eco top level domain. So you can find .eco domains on the internet. We operate the domain registry behind it, and we have an objective of being the world's first carbon neutral domain registry. So this has kind of set me on this path of going and calculating what our carbon footprint is, figuring out how we can make a commitment to net zero, how we can measure and offset our footprint, et cetera. Love to talk more about that experience, but hopefully this has given you some useful tips, resources, and a starting point on your own climate and carbon reduction journey. So thanks so much. Happy to open the floor to questions.
Well, thanks very much, Owen. This is really interesting. I have a question for you. The underwater data centers, what are your thoughts on those? Are they helping or shifting the problem somewhere else?
You know, I can't say that I know very much about them. I do know that cooling is a huge problem for data centers. That power usage effectiveness formula that I showed earlier on in the presentation, so much of that is driven by the energy used to cool the data center. And so running your data center underwater, like a lot of higher efficiency data centers use liquid cooling within the data center itself. Mm-hmm. So running the data center underwater is like basically building that cooling in. I mean, other things that data centers can do is they can then use that residual heat for some other purpose, as like a community energy facility, like what we've got in Vancouver with the wastewater from downtown being used to heat communities along False Creek, right? There's there's a bunch that can be done, but I mean, I don't know what the environmental impacts are specifically of underwater data centers. I also don't know what their availability is. Are there, I haven't read like any current cloud providers offering that. I could see like AWS or Google opening like their Atlantis region.
Microsoft, as far as I know, Microsoft has done some extensive testing in, I think, in the Irish coastline, but I don't know if that's actually just experimentation or if they're actually using them for real-time data center services.
Yeah, I haven't heard. I mean, they are definitely, these larger providers are doing some pretty innovative stuff in this space, which is great to see.
I thought there was a thing with Iceland where they were talking about government facilities that opened up and they were using their geothermal capability to power data centers. So as companies were looking for offshoring needs around data centers to use something like that to that effect. I don't know how big it's been or what the adoption's looking like, but I thought that was quite interesting.
Yeah, I know there's a place in Switzerland, one of the mountains in the Swiss Alps, that they have cooling in the in the center of the mountain for their high security, highly sensitive vaults, data centers, and other materials.
Anyone have some other questions?
There is a question in the chat. Isn't underwater-based data centers just moving the issue somewhere else, i.e., heading up the ocean?
Well, that's probably heating. Yeah, there it is.
Yeah, heating, yeah, exactly.
I don't know that I'm in a position to speculate on the impacts of whether it's a good approach or not.
So maybe another question, should we be switching our laptops off or leave them on overnight?
For the most part, if you're using a modern laptop, they're very energy efficient. So I wouldn't worry too much about it. Yeah, at this point, I would say it's not really a big consideration. And for the most part, for us in BC, again, like our electricity is produced pretty cleanly. So part of what I think is worthwhile, like what I'm hoping is one of the takeaways from this is by focusing on the web applications and services that we operate, you're able to think more at scale. So it's not just like, what is the impact of my individual footprint? But given the breadth of all of the users of my service, that's when the impact really starts to add up, assuming that you're working on anything with any decent scale. So measuring and reducing the bandwidth associated with the operation of your website or service will not only reduce your carbon footprint, but it will also provide the residual benefit of improving your performance.
Do you know when there will be the legislative approach for net zero, and will there be any carrot associated with that?
I don't. I mean, I think it's all going to be region specific. I wouldn't be surprised if the EU leads the way. So as they have in so many other initiatives, especially given the current political environment within the United States, it's hard to imagine the US being the place where this kind of legislation gets passed first. But yeah, so I think if you're operating in Europe, then I would that's where I would expect to see it. And it has been a very significant focus within the European community, especially given the recent climate impacts there.
Okay, thank you.
We've got a question from Stephen. What are some of the challenges you have come across going to net zero?
I really like for a lot. It really depends on the size of your organization. So the first challenge is being able to calculate your carbon footprint. The carbon footprint of your of digital services is going to be a portion, potentially not a particularly large portion of your organization's overall footprint. So if your organization is committing to net zero, then it's going to be broader than maybe your particular sphere of focus. But once you've done that calculation, then it's effectively two steps that you're iterating on from then. One is optimizing, so figuring out across the organization what steps you can take to minimize that footprint. And then two, there's always going to be some residual impact, at least with current technology. So the consideration then is what can we do, or what is basically how can we offset that? So that means at this point purchasing carbon offsets. Carbon offsets are pretty widely available. There's a large variety of projects that you can help fund that will attempt to draw carbon out of the atmosphere, whether it be planting trees or trying to help people move off of wood for cooking stoves in the global south. So there's a number of different initiatives that you can fund, and effectively there are calculations that are done that look at what the size of your emissions are, and then what kind of funding you would need to put into an offset program to offset it. All right, well, I think we're at time at this point in time. If anybody has further questions or is interested in this topic and would like to discuss it, I'm more than happy to do so. Feel free to reach out via LinkedIn or email. Yeah, as I said, best of luck on your own particular journey to help your organization reduce its footprint.
Thank you very much, Owen.
Awesome.
Very enlightening and inspiring presentation.
Yeah, it's very cool.
Right, so for our second session, I'm just double checking. I would like to introduce you to Rishi Yadav, the CEO and co-founder of Roost, with 2 decades of experience in leading enterprise application teams. And Rishi, I just want to double check. I think your partner in crime is delayed, or his flight is delayed. Is there anybody else?
Yes. So no, we do have Rakesh who's going to do the demo, and so the moment he lands, he'll be able to join. He has not landed yet, so we have to see when he's going to land. But yeah, so but we have a plan B in place. So.
Excellent. So I made you and Rakesh co-host, so you can share your screens. So gentlemen, the virtual floor is all yours.
Can you guys see my screen?
Yes, I can see it.
Yeah, looks good.
Okay. Yeah, so by the way, we great, whatever part I heard, great presentation, Owen. We recently joined GSF, the Green Software Foundation. We just had a press release out about it 2-3 days back. So yeah, pretty excited there. In fact, that is, so we are working with the the Carbon APIs of GSF. I know that Microsoft is also very deeply involved there. So anyway, so let's get started. So folks, today my name is Rishi Yadav. I'm the co-founder and CEO at Roost.ai. And today I'm going to talk about the Achilles heel in today's modern applications, and that is the pre-production environments and how our approach of creating the ephemeral DevOps environments solves it, cures it. So as you all know, the goal of any release is to take a change from development to production, hopefully without any collateral damage. So talking about collateral damage, so there are two paradigms which are being talked about a lot these days. And the one paradigm is testing in production. And both the paradigms are good, if not taken to the extreme. And you guys did see that if testing in production is taken to the extreme, what happens? There's another paradigm, and that is shift left, right? That's also being talked about a lot, and to the level of abusing it. And you'll say, Rishi, why are you not talking about pre-production here, right? You're talking about production, you're talking about development. And folks, here is the problem that today's pre-production environments, the way they are today, they're completely broken, right? They're static and stale, right? You have static UA, you have got static staging, then somebody has performance environment, and there are all sorts of different environments, right? And then there are different ways to put the baling wire and duct tape to make it dynamic, right? So, but what if you have dynamic environments to start with, and that's where we come in. So we create these on-demand ephemeral environments. So think about it this way, that let's say your repo is in GitHub, GitLab, Bitbucket. We're going to scan your repo, Docker file, Docker Compose, Terraform, Helm charts, other configuration files. And based on that, we are going to infer how your pre-production environment should look like, right? So that's number one. Number two is that when it's going to get launched. So there are two approaches to it. One of the approaches is more of a textbook approach here, is which a lot of customers use, is that you make its life coincidental with the pull request, right? So so when a pull request gets created, at that time these environments launch. They do all the testing, all the validation. It sends the URLs to the right stakeholders. For example, product managers always have this issue that they either had to wait for a release to happen, or they have to sit next to the developer to see, what's how the release is going to be, and are there any gaps, right? So Roost solves those problems, right? And when the pull request merges, at that time these environments automatically get deleted. Now think about it, right? So for every change, we are that is represented by a pull request, right? So for every change, we are creating an environment which is only made for that change and for nothing else, right? That's number one. Number two is that this environment is going to last only for the duration of its functional use, right? The moment a pull request merges, right? And in fact, this idea is not a new idea to us. We stole this idea from short-lived branches, right? So as you all know that till some point time back, few years back, there used to be permanent branches. You talk to anybody in private, and they would have a lot of horror stories to tell you about that, right? So nowadays, nobody uses, there's a trunk-based development, right? So for every feature, you create a branch which is specific to that feature, right? All the development happens in that branch. In fact, that branch works as feeder for us also. And once this feature goes live, this branch goes away, right? So think about it. So we are just taking the same logic to another level, right? So that not only for the branches which are short-lived, but why should not we have these short-lived environments? And the third benefit of the environment, as I started with, was that as member of the GSF, so now these environments you can run in a very carbon efficient way, right? So for example, if your source of electricity, I'm simplifying it, is dirty, then you maybe run least the amount of loads possible. If it's clean, then you run more, right? So there are multiple angles to obviously the whole the whole carbon efficiency. So anyway, so I will take a pause here before I go further for any questions. Okay, so so that was pretty much high level from my side on the presentation. So now what Rakesh will do is he will show you guys the live demo of the product, and if you have and I'm available if you have any questions. Feel free to ask questions anytime. It doesn't have to. You don't have to wait till the end of the presentation.
Hi, good evening, everyone. Let me share my screen. Give me a second. Hi, everyone. So myself, Rakesh, I'm the solutions engineer at Roost.ai. And I hope you can see my screen. I'm sharing one of these slides.
Yeah, it looks good.
Yeah. So as Rishi mentioned, Roost provides an ephemeral environment. So let me start with some of the use cases in place here before jumping onto the demo. So as you know that in the DevOps pipeline, there are multiple aspects of it, like the CI/CD, the deployment. And most of the times what happens is that in that deployment and CI/CD part, the environments are always static or shared, right? So in that case, most of these challenges arise where there are bottleneck in multiple aspects of that software development lifecycle, and even to the production level and in the marketing. So some of the use cases which I would like to present is from the QA perspective. So when a release cycle happens, most of the times what happens that even for a small change, the QA needs to wait for that change to merge into their QA environment. But most often, number of PRs will be in the pipeline, and one PR, all the PRs need to be merged for them to test the entire change. But with our Roost AI's ephemeral environment concept, so every pull request, every change, we create an environment. So the QA can directly go to that environment and test that change and approve it and provide constant feedback to the developer. So that is one of the aspects on the lifecycle where a group of QA can benefit from this ephemeral concept. And coming to the product team, when there are stakeholders involved, when there are any new features which they need to look into it and approve it, still they need to wait for that static environment when all the release, the changes in the PR needs to get merged into that static branches or the environment. And what happens is that it gets to a delayed point that they need to wait for that new feature to get deployed onto that environment, right? But in our case, like since we are creating that ephemeral, the product engineers or the product managers can, there is no gap between that development. They can closely work with that developer and whenever there is a change, they can visually approve that change as soon as when it is getting merged into that branch. So since that ephemeral environment provides a shareable preview URL, developers can share that preview URL and the product team can visualize those and approve it. And coming to a sales cycles, most often what happens in this cloud journey, like most of this demo happens on this environment, and this environment run 24/7. As you know that Kubernetes clusters, if you consider EKS or some other Microsoft Kubernetes clusters, they run for 24/7. So, but most often the demo happens only for a short period of time, and rest of the time it's not even utilized. So when it comes to an ephemeral environment concept, they can spin up their environment. Roost provides an option to spin up and shut down the environment with a click of a button. So whenever needed, they can spin up that environment. And when the demo is done, they can shut down this environment. So some of these success stories which I would like to share is one from an
So
enterprise.
just to add to Rakesh's point, right? So the key part here is this, that the whole release process is or when the release process is happening, right? You're getting the opportunity to give the live feedback here, right? So that kind of makes the value prop very, very interesting, right? So so this makes the whole release real time, right? So in fact, one of so when we made the release real time, we thought that we're going to get a lot of good feedback, and we did get a lot of good feedback. But one of the pushbacks which we got was that, you know what, I have a 2-week sprint. Why should I care? Right, which was pretty interesting, right? So okay, so you are making the release happen, let's say in 1 day or 1 hour, or I mean, we do it in minutes, but assuming that whatever their state was before that, right? So in fact, I wrote a blog about it, that that 2-week sprint cycle, is it really a sprint or it's a marathon, right? So it's kind of interesting that what was the innovation of the past, and I mean, I've been in the industry long enough to know those days when these sprints started, and I started. In fact, I worked on 3-week sprint, and only later in my career there were 2-week sprints, right? So, but even those 2-week sprints have become now they have become a kind of an obstacle to the innovation, right? Because we can make your releases happen in minutes, right? For most of the customers, it takes 5 to 10 minutes, right? But the processes have to improve there, right? So the whole dogmatic approach of having a 2-week release cycle in which or 2-week sprint cycle in which everything can wait for that doesn't have to happen, right? It has to accelerate much more, right? And one of the ways to make that happen was that when you get all stakeholders, right, in the team, right? So not only QA but also the product team, also the sales engineers. Is kind of it's a separate case in which a lot of companies, they need their demos to be done in real time, and the sales engineers struggle there, that, you know, how can I make not only the demo available fast, but also I have the latest feature available in the demo, right? So anyway, so those were a few more quick tidbits about the value proposition of Boost. So yeah, Rakesh.
Thank
Yeah,
you.
and feel free to ask if you guys have any questions anytime.
So this is from one of the use cases which I mentioned above. So one of our customers, the sales engineers do product demos, and the issue was that they were provided static clusters, but the utilization was pretty much less than 5% globally. So there was significant expense added on to their revenue because they had to spend a lot of money in that areas. And one of the other thing is, like, the Kubernetes clusters are clumpers. So whenever something happens, the technical team needs to be there assisting the sales engineers. So there needs manpower to support them. So our solution had this controlled the amount of time your cluster runs and gracefully destroy it. So they were able to reduce the cluster cost by over 80%. So that is one of the customer success stories. And other was for an industry.
And no, and just to add some color to it, right? So when Rakesh, you talk about cluster, right? So for some customers it's cluster, for some customers it's the namespaces, right?
Yeah.
So because I call namespaces the Swiss Army knife, right? So they can be used for any purpose possible, right? So in fact, most of the customers go for namespaces. Smaller customers, like the customer Rakesh talked about, they went for the full scale clusters.
Yep. Another for an industrial AI organization, here there were a lack of automated testing, and their service not being certified or tested completely before release to the production. Since for this, they had like multiple services, like more than 100 services, and the dependencies involved in these services was causing a lot of complexity for them. And when there is a shared environment, so one service depend on other service, and that dependency is not being tested here. So whenever a change happens on one of the services, these services, the testing is not automated, and they miss that dependency of that services, and that cause issues in the production at the later stage. So it becomes very difficult for, they find that issues at the later point, and there was a high failure rate. So our solutions provides a pre-production environment which creates a environment at every pull request and feature branch. And we provide automatically, we provide the test environment where we automatically maps and discovers the environment configuration. So the dependency graph is available. And whenever Roost finds that change is happening in one of the services, based on that dependency, it will automatically find out that, okay, this service is dependent on so many other services, and it will make sure that all these services are dependent services are tested, so that these kind of issues doesn't occur in the production. So that way we solve this dependency issues and automated test environment. So I'll show that in my demo in a minute.
So it's almost like this, right? That like a lot of kids in college, right? They would like 4 kids or 3 kids, right? They would buy a car, right? So and it's going to be shared car, and then they're all of them are going to use that car, right? So and then compared to that, I mean, of an Uber, right? What if you don't have to buy a car, right? But you get a car on demand, right? I mean, again, standard cloud use case. You guys all know it. I don't have to explain the on-demand part here. It's just that we are bringing on-demand to these pre-production environments, right? So and the shared environments are big. I mean, every customer we talk to, they always tell that how big a pain point these shared environments are, right? And especially when it cuts across teams, right? It becomes a huge pain, right? I mean, so I know from my own experience that. What kind of a I would not even call it embarrassing, but when I was working at a very large bank, it was almost political when it came to those environments, right? That okay, when you have limited resources, right? So I mean, who's going to get is not only a technical decision but also a political decision.
So yeah, so this is the Roost UI. So let me just log out. So it's a private SaaS plane, and we provide integration with Google, Microsoft, and GitHub, and others as well, third-party integration. So once we log in, this is the dashboard. So we have, as you can see here, we provide services in 3 aspects. So one is for the teams. For the development teams, a DevOps admin can assign a cluster to a team and provide more granular control to them, like how many namespaces they can create, or how many clusters they can create, for how long it can create. So we provide that granular control over the clusters that we create. One is, and other is the cluster dashboard. We provide bespoke Kubernetes cluster. So there are 2 aspects of it. You can create your own cluster. We provide both all the 3 clouds like AWS, GCP, and Azure. So in here, you can specify the AMI and the instance type, and also the spot instances in that version, and the Kubernetes version. So one of the important features is that we provide heterogeneous clusters as well, and also the number of hours, as you can see here, the number of hours this cluster needs to run, so that it doesn't need to run 24/7. We provide it in an ephemeral way. And you can also provide the install scripts and uninstall script. Like if you want to add some of these dependencies or any other tear down mechanism or the scripts, you can choose it here. And there is also notification available for Slack and other communication channel. And so this is about Roost cluster, and other provide is remote cluster. If you have a existing Kubernetes cluster in any of the 3 clouds, we provide an option to add that kubeconfig and connect with, so that you can manage those cluster in a way that like same kind of granular control can be implemented. And also you can add like expiry or how many hours it needs to be run. So if you feel like, okay, there is Thanksgiving holidays coming or some shut off coming, you can manage that gracefully shutdowning that cluster for that period of time. And other aspect is the environment as a service. So where we can define the configuration. So in here, I'll take a existing workflow. So assume, so this, in this, we have 4 microservices and we have this GitHub integration in here. So the first part is deciding your infrastructure, right? So some of the clients or some of the customers will be using the existing AWS infrastructure and or other GCP or any other clouds, right? But in that infrastructure may be created using some of these infrastructure provisioning tool. So we have this ability, the support or integration with Terraform and also the CloudFormation. So if you are using Terraform or any other infrastructure provisioner for you to spin up your cluster and all the services, you can directly give that here. So we take those Terraform files and spin up that cluster for you. So we have that tight integration with that. And once the infrastructure is there, so the second part is the application dependencies, right? So when you build an application, there are different aspects of it. What are the prerequisites? And as you can see, once you give your GitHub repo, Roost automatically scans the repo and find out all the Docker files and other files existing. So you can directly add it from here, or you can give your own script or a file or a build back. So we support all the 3 options. And also same like deployment steps also, we support your deployment tool. Currently we have like Argo CD or from a script. If your deployment scripts are saved in the GitHub repo, we will automatically find that YAML and it will be available here. And you can use that or you can write your own script. And if it's any other tool, we provide custom integration as well for the deployment. So we have a team to do that, and we have an event framework which you can define that events, what events you need to trigger that deployment to happen or the configuration to change, right? And coming to the test, so once you define the dependencies, once you define the deployment part, then it comes to the testing. So we have currently integration with 6 testing framework, and in here it automatically identifies those test files, and you can like drag and drop and select those test files. And the last part is once you define the testing, then the uninstall part. So if you want, whenever the PR is getting merged and you want to place any script for the tear down, you can give it here. So that way you define the application. And coming to the next one is about your cluster. So either you can create using the Terraform itself, or you can define the cluster here. If it's an AWS, you can define what kind of cluster you need. And same way, you can define the Kubernetes configuration and other aspect here. And as you can see here, you can set the cluster expiry, like how many hours this cluster needs to run. And the third part is environment. So this is where Rishi mentioned before. So some of the enterprise, there may be multiple clusters, and for some it will be multiple namespaces within the cluster. So we do provide that option. What kind of environment preference you have. So in the cloud, you have a cluster. If you want to deploy that every change in a new namespace every time, then you have that option. Or for every change, you create a new cluster every time. So that is the second option. And every time you deploy to the same. So that is also available. So we provide granular control over your cluster, over your deployment, and how you define your infrastructure, right? So all the 3 aspects, we provide that to make it in an ephemeral way, so that you don't have to worry about the static environment where there is a bottleneck in testing or the changes being released to the production in an accelerated manner. And finally, we do have third-party configuration for Slack, where all the changes happening or the events occurring will be notified in your Slack or any other. We do support Microsoft Team as well. So all these details, even that after the test, it will show all the messages there like, okay, current deployment is happening and these are the test results, and even attach the test result onto that Slack thread. So I'll just show you a quick
But let's take a pause. If anybody has any questions so far. Okay, continue.
I have a quick question.
Yeah.
Does this also work within the Azure DevOps sphere?
Yes.
And how do you? Oh, so it does work within Azure DevOps. So you can deal with that, or can you deal with your own providers?
No, yes. Yeah, so we are pretty much cloud agnostic. So we work with the 3 large providers, obviously, and besides that, because if somebody is even on-prem, we can work with that, right? So yeah.
Okay, thank you.
Yeah, we do work on Azure DevOps. Yeah. So give me 1 second.
There are some questions in the chat session.
So let me quickly log in 1 second.
So one question is, how do you automate testing?
So we don't automate testing. Okay, so let me put it on another words, right? So we are not a test framework. So what we do is that we integrate with your existing test framework, like as Rakesh had shown 5 examples. And if you have a test framework which is outside those, then Rakesh, you can list those test frameworks, right? So, and then we can also do a custom integration with that. So we don't, so here is, so where we are and where my vision is, right? So currently we are integrating with all of your test frameworks, and slowly what's going to happen is as the AI capabilities of Roost become more and more mature, the need for writing, handwriting these test cases is going to reduce, right? So because the core tenet which we work on is that service is a first-class citizen, not the code. So, so a service should be able, I mean, you can call it contract testing, but that's going to be oversimplification, right? But if that puts it in the right bucket, right? So, so slowly these services would dynamically be able to figure out that, you know, that what interfaces need to be tested or not. But as of today, yeah, we integrate with test frameworks and all the leading test frameworks. So that's what we do. I don't know if that, does that answer your question or?
Christine, does that answer your question? Yes, it does. Another question is, how does this compare to ECS Fargate?
So ECS, it's a container solution, right? So we do provide multiple aspects of this entire CI/CD deployment. So as you can see that from a infrastructure provisioning to the deployment, right? So we have that flexibility to control on each stage of this DevOps pipeline. From spinning up the infrastructure using Terraform or CloudFormation, then based on the Kubernetes cluster, right? We have integration with the Docker registry and ECR. So we provide more support when compared to the Fargate. We cover more areas in the complete DevOps space.
Okay. Any other?
Okay, and yeah, so, but as I said, I mean, the key aspect here is that, I mean, if you have to let's say you meet somebody at a bar and that person's asked that, okay, what do the folks at Roost do, right? So that's the ephemeral part, right? So ephemeral DevOps environments, that's a key part, right? I think that these environments get created automatically, and then they get destroyed automatically, right? That ephemeral nature, that's the most compelling use case here, right? Everything else is just to enable it, right? So the idea is that to take it from the static DevOps, right? So I mean the QA and staging. In fact, what I tell a lot of people is that production is cool. I mean, people love to work on production. It's easy to get funded on production and all those things, right? Because obviously that's the reason there's so many monitoring companies, right? Right. So I mean, it's easy to get budget on that and all that, right? So then the other aspect is the developers, which got glory in last, I would say, 10 years or so. Whatever is between development and production is the boring part, right? So I mean, if you look at it in the ideal world, I mean, if you only have ideal developers, right, and who breathe ideal gas and drive on frictionless surfaces, right? So in that case, you don't even need the stage which we are talking about, right? So you have the development stage, right? You have that, or let's call it using the 12-factor principle, the build stage, the release stage, and the deploy stage, right? So if you look at the release stage, right, it's not that we are creating anything new, right? We are just promoting, right? So the artifacts which you get at the images which you created in the build, the whole release process is just to battle harden them, just to make sure that they are right for production, right? But the input and the output of the release, hopefully, is the same, right? So that way, what happens is that the release aspect, though, is most crucial, but doesn't get as much attention, right? And that's where we are solving problems, and that's a problem we are solving, right? Because we are putting it right where the whole process is, and that's and a big thanks to the whole pull request and the whole movement around it, right? Because that kind of put the change. Because in the old school IT, there used to be something called change management, right? Change management was to control the change, right? Not to embrace the change. But what we are doing with the pull request in the industry is that now we are embracing change, right? Change is good. Change should be fast, but change should be safe, right? So for that, so the whole pull request and the way change is becoming a first-class citizen, that these two are the giants which we are, whose shoulders we are standing upon.
I got a question. You've used Kubernetes quite a bit and containers. Are those requirements?
Kubernetes is not a requirement, not at all, but containers are. So basically, our platform is made for the modern applications, right? So I mean, this question comes to us all the time: that do you work with the legacy apps? And we made a decision that that we would work with the. I mean, if the applications are not containerized, we do have a services division which can help you containerize that, but the only requirement we have is that your application should be containerized, and okay. Even if or services, and even if they are not all services, right? Let's say your 20% services are containerized. That's a good start, right? So because then you'll have the right practices in place when you containerize the rest of the application. So at least you need to have the container roadmap. I think that's the only requirement we have.
If you had an application that was split, had multiple containers, and you deployed them, can they interoperate?
Yeah, absolutely. So number one is that, so container, obviously the container image is more of an artifact which you use, but container is not live. What goes live is a service, right? So we do, so we work across services. In fact, Roost automatically loads the upstream and downstream services. So one example I always give of that is that, let's say you have to test the road networks in Hawaii, right? And now they have what, 3-4 major islands. There are some smaller islands, right? And you start test. So every time there is an issue or there's an upgrade or anything in, let's say, Kauai, you're going to test every road in every island possible, right? What we are going to do here is this. Now, the road network in Kauai is not same as the road network in Maui, right? In fact, they're separated by the deep blue sea, right? So what we do is that we take a subset of the services which actually are going to be impacted by this change, and we only test that subset of the services, right? So that's the key part here, right? So the behavior is the primary citizen here, right? That's so basically the testing for the behavior change and testing to make sure that behavior is as expected. That's the primary thing. Everything else is there to enable it. For example, some customers, they want multiple PRs to be part of their certain workflows. That's not a problem, right? So you have multiple PRs, you have multiple services, whichever way you put it, right? The key part is there's a business functionality, every change. I mean, if you look at change, right? I mean, what is a change, right? So I look at production as a state machine, right? So production is a state machine, and every change mutates the state of that state machine, right? That's what it is, right? And the state before that change and the state after that change has to be consistent, right? So that's all. Is I mean, if you look at it from outside as a black box, right? That's what it is. Now, how do you enable it, right? That's all. Obviously, that's where all the details come into the picture. But details are not as important as the real objective, right? Which is to propagate a change from development to production in the least amount of time possible and in the best way possible. And that's what we do, using a very, very unique approach, very innovative approach of creating the environments only when they are needed, right? So for example, I'm in Detroit today, and so I had two choices, right? So it's a car, it's a motor city. So one choice was that when I landed, I just buy a car, right? And then I get to the hotel, and then after 7 days, that I can maybe dump the car or do whatever, right? Or maybe sell it to somebody else, or again, the same use case, you guys know that. But I took the Uber, right? So that's what we are also doing, right? So it's kind of an Uberization of the pre-production environments. In fact, this was the only part which was left, right? Which was not converted to as a service.
Yeah, so I'll quickly show a demo of how the environment is created. So this is one of the services where I'm making a small change in one of the file and creating a pull request. So as you can see, the instant when the pull request was created, the workflow got triggered, and it is creating that environment for me. And it will, so when we, as a recap, when I showed that workflow, right, it was showing the infrastructure dependencies, the application dependencies, the deployment, the test. So this will trigger that entire workflow. It will create that environment and deploy that application. So it will take some time. So I'll quickly show one of the application which already existing. So one aspect is from the logs, right? So it provides all the logs. Like if you're using Terraform, then it will have all the logs, what happened with the Terraform deployment, and the cluster creation logs, and build and deploy and uninstall logs. So it gives you a ability to see that visually, like what happened with each of these from a logs perspective. And other thing is, if you go to this cluster dashboard, as you can see, this was one of the environment which I created a bit ago, like 2 hours ago. So you can directly go to that service witness, and it gives you a dashboard which automatically says, so this is not in the correct namespace. So this was the namespace for that specific PR. And it will show all these deployment happen, like an overview of what are the resources and the containers and pods. So if you go to pod, if you click on a pod, it will give you all the utilization, they even happen. So you get more insight on what happened on your deployment, and what are the services happening, the endpoints and everything can be visible from here. And other thing is we have a namespace view. So this is the entire cluster, what's happening. So you can put that namespace to sleep for a specific amount of time, so that the entire resource utilization for that specific cluster in that namespace goes to 0. And whenever you need it, you can bring back. So on a namespace level, you have more control there, and everything is treated in an ephemeral way. So you spin up when needed and shut down when not in use, right? And so this is another event viewer where whatever happened with that deployment, if there is any error message or Kubernetes namespace, what is deleted or whatever change happened in that environment will be visible here. And we do provide support for our own registry, so you can push your images there, or it can pull it from. So if you don't want to use the build part from us, and you have already a build tool, then we can connect to their existing repository and pull those images from there and deploy it for you. So in a way, Roost can plug into different phases of your DevOps pipeline, or you can use it for entire DevOps pipeline where we control, or you can control the build, deploy, and the test from the Roost itself. And this is another aspect in which I talked about the dependencies. So for this specific deployment, we deployed 4 services, and it shows a dependency graph. So this is what I told. So next time, whenever a change happens, Roost is automatically identifying, okay, what service is dependent on what. So if, for example, if we make a change in one of the service, it will automatically detect, oh, this is dependent on service A and B. So it will do the testing for that service as well. And you'll so that you don't have to face any issues about the dependencies from the production. So any questions, please let me know. So 1 second.
Okay, our CTO has also just joined. Obviously, his plane has not landed yet. It's taxiing, so it's still safe. But if there are any questions, he can also chime in. So. But as I said, I think the key takeaway here is this, right? That I mean, one thing is obviously what we do, but the bigger part is that why we are doing what we are doing, right? So whether you use Roost or our competitor's product, obviously you're going to use us because we are far better. But the key part here is this, that the power of ephemeral environments, right? I think understanding that is very, very important, right? So because in today's day and age, if you are using static environments for your DevOps, it means you are doing something terribly wrong, right? I think that's the biggest takeaway here, right? That I mean, I started working on CI back in 2004 using a tool called cruise control, right? So the old school CI/CD has been that old, right? So I mean, and that obviously was actually created in 2001, right? So this is but for today's the whole Git-oriented applications, right, and the dynamic applications, you cannot use. I mean, I don't think any of you are using a 21-year-old car, right? But you are still using the technology which is that old, right? So that's what we are changing. We are saying everything else has become dynamic, right? As I said, I mean, all the way from the Ubers to the cloud and everything, right, is dynamic. There's only this big gap left, right? And that gap is left because it's a very uncool type of an area, right? Because I mean, QA people don't consider that cool, but that's super crucial, right? Right. So whether it's a QA or the staging and all that parts, right? And that's the problem we are, solving. In fact, I already told you guys about the one part of my vision. You can call it Vision 2030, right? And that part was that the dependence on writing actual manual test cases is going to be very, very low, if not completely eliminated. My other vision is that the SRE as a role. Now, you guys can argue that it may be called something else, maybe DevOps engineer is going to be called, but there's going to be this one all-encompassing role, right, which is going to emerge, which is going to be in addition to the application developer, and which is going to be in addition to the cloud ops engineer, right? And this role is going to be a very interesting role because this role is going to be of a team or people who are going to be Trojan horses for the customer, right? So here, the whole, whether the SRE, DevOps, all this, because today SRE is obviously post-prod, is all going to expand. So these people are going, these engineers are going to care about how customer is looking at the things, right? Rather than how a developer is looking at it, how a company is looking at it, right? So that's going to be another role which is going to emerge, and it's kind of empowering those folks who have been underprivileged so far, right? Whether you call them QA engineers or support engineers or whatever, right? And kind of upskilling them, right? And making them part of the whole cycle, and as a benefit that also makes everything fast, everything better, right? So this, anyway, I'll take a pause here if any other questions. And we are available. So if you guys, number one, as I said, that if you are not thinking about ephemeral environments, you're doing something terribly wrong, right? So especially in 2022. So learn more about ephemeral environment. We will be more than happy to guide you guys there. And if you want to learn how you can use them in your specific use case in your organization, there also we would be more than happy to talk to you. So the organizers are going to provide you the information about us, or please check out roost.ai. Right. So if you guys are the folks in America and other people, folks who are also traveling, if you are in Detroit, we are here for the whole week for the KubeCon. So feel free to ping us, stop by our booth. But we would love to continue the discussion.
All right, very good. Thanks, guys.
Thank you very much. Owen, Rishi, and Rakesh, thank you very much for your presentations. And also a special thank you for Ilse and Martin for helping with the backstage support. As mentioned, we will share the recording and content shared by the speakers in due course. And also keep an eye on your Meetup inbox for a quick feedback poll. Other than that, have a safe and warm evening, and see you again on November 29th. So I'll switch off the recording now, and then we can just have an open chat if you want.
Thank you, everyone.
Great, guys.